All right, so what stage are we at here then?
Right, so, okay. So we've developed a Python version of what we're currently developing, which is originally written in the MATLAB code.
Yeah.
So this is the very basic representation of it, wherein using this from the paper to detect the convoy, we have different features basically. One is the distance between two vehicles and the time taken, captured by one ANPR cameras. So that should be considered on the code to detect the convoy. Okay, here, so basically we've defined it in the code, wherein we have our randomly generated vehicles for now, and then the randomly generated ANPR cameras, wherein it's gonna be here.
Right.
Because the blue dots are the ANPR cameras, and you have here just randomly roaming vehicles.
Right.
So what we want are for these ANPR cameras to detect these vehicles. Okay, so for that to happen, this vehicle should appear or be captured by multiple ANPR cameras for now, right? So it's moving randomly.
So it's a random. So at the moment you have one camera. Right. Where the car goes past it, it's recorded.
Yes,
right. It knows the system will know that, and so one camera, as soon as it detects a second like a convoy, it will then be your system kicks in and says, right, we've spotted one convoy.
That's correct.
And then you're looking at the consistency if other cameras pick up the same, right?
That's correct. Yeah.
Okay. So obviously in a vehicle theft scenario where you have organised criminals stealing cars. Obviously, what they're trying to do is pick up 2 or 3 cars, maybe 4 cars in one sitting, right?
Right.
So obviously, I guess once we actually get actual data, you're able to add. So those blue dots then become actual cameras on a map.
And actual cameras.
Cameras on a map, right? Yeah. Okay. So at the moment, obviously, we've got the general convoy analysis happening, so that's fine. That makes sense. Did you have any issues in coding this, or what did you have to do additionally to the MATLAB code?
Yes, there are. So technically, in terms of MATLAB code, is quite. We have an old script from MATLAB, which is written way back in 2016. So I think one of the challenges converting it into Python code are the syntaxes, as well as the functions present in the MATLAB code.
But you replicated that MATLAB into this Python, so that's a straight replication. Or did you just
not 100%?
Right.
But I would say most of the functions are also present in the Python code.
Okay, right.
So.
And how much time is that roughly?
So on this, it took us around probably 2 weeks.
2 weeks.
2 weeks.
All right. Okay. Yeah. So optimizing. So using machine learning. Obviously, once the convoy is adapted, one convoy is detected. I guess no work has been done yet on learning more convoy patterns. That's the aim, though, right?
That's the next phase.
That's the next phase.
Yeah.
Right. Okay. So with actual data, so you train this on synthetic, right?
This is trained on synthetic data.
Yeah.
So one real ANPR camera generates 7 million lines of data. So we generate a synthetic version of that, and we use it here.
You haven't got that synthetic data?
I can show it.
Yeah, let's have a look. So there's a few things in there that we have to think about when it comes to the next stage of product development. When it comes to the use case, right?
Yeah.
So the use case is obviously, like I say, in this particular scenario, is organised crime, organised criminals stealing cars in, obviously Range Rovers and other high-powered vehicles for either conducting other crime or for selling on or chopping up. So how the actual system will work. So this is where the high-performance compute comes in, and obviously the machine learning part as well. So your synthetic data set is how many lines?
That's 7 million lines.
Which represents about a day's worth, right? In a typical
right.
sort of large UK city. So 7 million lines in one day. So within that, depending on where you are in the UK, let's say 30 vehicles are stolen. That's an average. So you could have 40, 50 in one. You could have 10, 15 in another night or day, because they do happen in a day as well. And so how does the system then, how will the system be able to then detect convoys throughout the day? This is not something batch processing, right? Where at the end of the day, you take the ANPR data, you feed it into the compute, and then it comes out with, okay, this is where the convoys are. It's too late.
Yes.
Right? There's got to be a real-time aspect to it. So what you show here, there's got to be alerts that come out to say convoy detected, and someone has to intercept, right?
So it's either, once there's a convoy detected, it's either gonna blink,
right,
just to represent there's a convoy detected, but ideally, once a convoy is detected, there would be a pop-up or an alert that will be sent to the authorities.
Right. Because the other part of this is something we're discussing with a transport agency is when they talk about taxi optimization, so where the customer is, and the right taxi would go and pick that person up, depending on the traffic.
Yeah.
Right. So you could probably get a version of that into this, or wherever the police cars are placed. Okay, which police car, not which is nearest to the convoy, but if it can predict the trajectory of the convoy, as to how to cut it off. Right. So it's a different type of optimization that needs to take place. Okay. So while that's loading up, so talk about the data set. It's ANPR data set, right? So all automatic number plate recognition. Yes. Is there a need for any image recognition to detect the convoy?
No, there's totally not, because what we are currently utilizing are the metadata,
right,
which is generated by the ANPR camera. So we're not dealing with any raw videos or raw images at all. So it's just all metadata.
Right. Okay, so maybe I'm just trying to think future iterations. Would it connect to like the DVLAs, like the database of number plate recognition? The good thing I think with this type of system is you're only looking at behavior patterns. You're not having to recognize what the number plate is. So even if there's a misread, it doesn't matter.
Yeah.
Right. It's not detected. And even if someone puts a false number plate on there, again, it doesn't matter.
Yeah, it doesn't matter. Yeah.
Yeah. Okay, so the number of detections in a day is obviously going to be in the, like I say, let's say on average, it's we're taking the West Midlands as an example, let's say London as well, it's like 30, 40 on average. Even we're talking to the police in India as well. Obviously the big metropolitan cities have, again, those sort of numbers. The smaller ones obviously are much less. But you still need fast level compute, and you need to be able to interrogate the data on an ongoing basis, right?
That's correct.
Yeah, so what you're doing here is, you've represented the cars moving around, and obviously you've got the cameras. Yeah. So how is the code? The code is running continually over the data. Is that what this is?
Should be. That's the aim. It should be a real-time detection, wherein you just have your code running all the time. Yeah. And of course, to be able to do that, you need to have the high-performance compute, which is running the code, basically. Yeah.
So is there obviously the MATLAB code that you got, was that designed for that, or basically you look at simulation, right? So the idea is when we give you actual data and what the synthetic data will do, can you simulate that and show it to somebody, say, well, actually, or is that still far away? Is that something we need to do with actual data? Because obviously there's programming time, right? You haven't got time to be doing it on synthetic data, right? Yeah. So is that a more complicated development?
I think that would come once we have access to real data, right? Because first of all, we would have real scenarios, real convoys in there, as well as a diversity on the data as well. Right. So that's really.
There's no point doing it that early without, because otherwise you're assuming way too much, aren't you? So go on. So this is the synthetic data you done. Do you want to explain how you put this together?
Yeah. So basically, what we need to generate the synthetic data are just the columns included here. Like for example, you have your vehicle make, your camera name, which is very important in the analysis, as well as the license plate and the capture date and others. Right. So basically, that's all we need. These two rows right here, and then based on that, we generated 7 million rows.
7 million as well. How long did that take?
So using a normal workstation, that would take you like probably 3 hours or 5 hours to generate. But if you have a much more powerful hardware, so that only will take like minutes. Right.
So the thing is, obviously with simulation, so you've done obviously one day. One of the part of the challenge statement is obviously there's a bandit car. So organized criminals will use one car, which is their business car, if you like, and it will show up in obviously doing the crime itself, right? Because as we said, it's a bandit car, but also it'll be used in the daytime.
Yeah.
So the daytime, it could be the criminal's mother's car or grandfather's car, right? And usually these cars are like, a bit older, or they could actually be another stolen vehicle, which someone uses in the daytime. So the idea is that when you have multiple days or months or whatever, so generating synthetic data is not an easy task, because obviously you don't want to spend too much time on that again.
Yeah.
And also being able to sort of, every day is different, right? You have rainy days where there's less cars, and there might be a football game on or something. There's always behaviors which you can't simulate. It takes too long, right, to do. So doing the one day is probably a good starting point for the moment, right?
It is, yeah.
So when it comes to, again, going back to the real-time aspect, that's what the real challenge on this. I think and you'll agree, hopefully, is that the actual coding side of it is a bit more straightforward. There's not complicated data sets. You're not going really beyond the ANPR data set, right? No. And you've obviously got one sort of thing that you're looking for, right, in terms of the convoy. But when it comes to, again, when the data comes in, because over 7 million lines represents one city, it represents a city. So within that city, you've got a number of obviously cameras, you've got obviously everyone's car journeys going on. You're trying to find 30 cars. And out of that, probably 40-50% of those 30 cars are actual stolen ones, right? That's maybe 3 convoys, 4, maybe 5 convoys at a max, right?
That's correct.
That's going to be hard to find. Obviously, humanly, yes, a team of 100 people probably could find it, but not quick enough. Yeah, not quick enough to be able to organize themselves to do it. So what you've got is a situation where, as the algorithm is running over the lines, at the moment, what you're doing, you haven't simulated this in real time. You haven't done like a digital twin of this, or anything like that. Is that something you would look to do?
Yeah, definitely, because I think digital twin would be able to visualize all this data right here.
Right.
Like, for example, if you have your longitude and latitude included, so we would be able to visualize it and actually apply the algorithm on top of that, so that we can simulate it in real time as well.
Right. Because I think from an operator's perspective, once they see a convoy maybe goes, I mean, we don't know what the police threshold is.
Yeah.
If they see a convoy let's say the algorithm says after 3 cameras, if it's in a convoy, there's a 60% chance of it being a stolen one, right?
Yeah.
But the police threshold maybe actually, no, it has to go through 10, right? Which is understandable. But obviously at 10, they may be heading towards the border, where there will be another ANPR region. Right. So that's obviously the interesting part. I think because again, from a technical standpoint, you can develop what you want onto this, but what do the police actually want out of this? That's what you've got to figure out. So when it comes to HPC, obviously Ranish is in the office as well, but when it comes to HPC, you have to be able to apply. Is this sequential programming? Is it sequential processing, or is parallel the best? Or do we test on both?
Definitely, we don't have any problems on testing on any scenarios because we have the HPC. But as I said, it's a parallel.
It is parallel, right? Because.
So just going back on the MATLAB again. So you've asked whether the MATLAB algorithm that we have is optimized for GPU computing, which is currently not. So that's also one thing that we are considering to optimize the code for parallel computation. Because basically, that's how we can maximize the HPC, which is, basically for parallel computation.
So okay, let me put this in layman's terms. So what you've got is you've got these journeys. So you've got 7 million lines. You divide that by 24. That's what, 400,000 lines per hour, something like that, right? So but again, you have to ping this every 30 seconds. The script will have to write, so every time, let's say 100,000 lines come in within a set period of time, you have to go through all that to see where the convoys are.
Yes.
Right? So every time the next 30 seconds of data comes, you have to check where the convoys are, right?
That's correct. Yeah.
So that hasn't been done yet, has it?
It hasn't been done yet.
Right.
Yeah.
That's what we've got to work towards. Right, Ranish?
That's when we need HPC.
That's when we need HPC, right? So that's where I think the real benefit is. Sometimes you can have a simple challenge statement, and even simple to some degree coding to some degree, but it's going to come down to obviously how the parallel processing and how the real-time aspect of this is done. Obviously, data streaming. Do you set it up into blocks? I think that's another thing that you can do.
That can be considered.
Right. So as the blocks of data comes in, they're all segregated. They go in, they get processed, they come back out, and they get mixed with all the others. Is there a new bit of code that comes into that? So that's the developer challenge that you'll have, right, as an ongoing piece. And also, I think the other thing that with bandit cars, especially bandit cars, because they're again, so the police will have two options, right? One is to go on a chase, and then that's a risky thing. The second is you wait for the robbery to happen, but you've got the bandit car actionable intelligence. So the relatedness technology comes into that as well, or the algorithm comes into that as well. How is the bandit car related? Can you find within this data set a related car that is basically involved in all of those convoys? Sometimes the convoys are a mile apart. You might have stolen cars and they're a mile behind.
Right.
The bandit cars are a mile behind, only because if there's a chase, they might end up somewhere else and and do that. So convoys are always going to be a different way that they're gonna operate. Okay, so I guess the next stage of this will be waiting for actual data.
Correct.
You get some more, obviously, development time. When with the actual data makes life a lot different, doesn't it?
Yes, it will make a lot of difference. Yeah.
And some of the behavior patterns. Obviously, we've got a domain expert who will come in on that as well. I think it's interesting. We've had a couple of calls where we're using the point of view of the end operator, what they're looking to see, right? I think the other thing that will come into, which again was mentioned yesterday, was you're not trying to intervene, or you're not trying to replicate a model of what's happened in the past, in the sense that police usually do an investigation. You're not trying to speed up that investigation. You're trying to action this in real time for proportionate intervention, right? So if there's 3 or 4 cars that are going at high speed and this detects it, that's a danger to the public, and you're able to react proportionately. That might need the helicopter to go out and things like that, right? Yeah. So you'll learn that with the end user and the domain expert as well.
Definitely.
So so next time we'll update on it. But you see, hopefully the ideation part is not simple, right? So the idea of these types of sessions, I think, if we work on the other ones in the same way.
Sure.
All right. Cool.